hopefully I didn't mess this up, but I was planning to ask you about vocabulary questions for assignment 2.2 before you saw this video. I'm hoping that you've already asked me vocab questions. If not, please make sure that if you had any vocab questions, you circle those and make yourself a little note that you have to come back and ask me stuff. Cut me a little slack. I really think that YouTube is helpful, but I do depend on you to come and ask me some questions. It's hard for me to organize, and I don't really know what you need help with because we're not in the same place. I can't see it in your eyes. So please ask me if you need help with the vocab, okay? There's also a few study goals in assignment 2.2 that are basic, just some getting into ecosystem stuff. Some of you don't have a strong science background, so this could take you an hour to catch up on all these study goals, but I have to assume that most of you are juniors and most of you have taken a couple science classes, so most of you will be comfortable with some of this stuff, and I'm going to go pretty fast. I want to discuss the 4 study goals that are on the screen right now. Okay. We know that chemicals cycle through life. So carbon dioxide is in the air, then it goes into a plant, and that carbon now lives in sugars. That plant can get eaten by an animal, so now those sugars are inside the animal. That animal can exhale, and so the carbon moves from the atmosphere into living stuff back to the atmosphere, whatever. And there's other cycles that put stuff into rock and into water. We call these the biogeochemical cycles. And I should probably rephrase this question. In your study guide, I said, how much time do chemicals spend in each? And really, that's probably not the best way to say this. So keep in mind that the 4 layers are the atmosphere, the biosphere, the hydrosphere, and the geo or lithosphere, meaning, the gases, the life, the water, and the rocks. And you can probably imagine, without a specific number, that once a chemical ends up in rock, it's probably going to be there as long as that rock stays rock. So, that granite over my shoulder in my background photo, that was probably made, I don't know, a few 100 million years ago, and it'll probably stay granite for a really long time. So the stuff that's in rocks, that's really slow to cycle. It takes a bazillion years to make a rock, and then it takes a bazillion years on average for the rock to stop being rock. Stuff in the atmosphere, that's really fast, right? If somebody cuts a nasty fart on the opposite side of the house, you might smell that soon because things move through the atmosphere very, very quickly. Atmospheric chemistry is almost instantaneous. It's so fast. So this is what I mean, the relative speeds. Stuff in life is slower than the air. Stuff in water is, usually a little bit slower because there's a lot of water. So like if carbon dissolves into the ocean, that could stay dissolved in water for, months or years or decades before it becomes rock or goes back to the atmosphere, goes into life. So the 4 layers are the gas, living, water, and rock, and they go fast, slower, and very, very slow. That's it. Number 13 are the big 6 most common elements in life. You should definitely know what they are. The book is really mellow, you got this. But the book doesn't tell you how sulfur is most often used in living things. Sulfur is most often used in our amino acids. Those are the building blocks of protein. If you've had a nutrition class, you might know that there are 20 different amino acids and you assemble them differently for different types of protein. So sulfur has a lot of other places where it shows up in life, but mostly it's in the amino acids. In number 14, there's a few basics about chemistry. The College Board does ask about pH, how many hydrogen ions are in a solution. Remember that a small pH number is acidic and a large pH number is basic. So 14 is really base and 1.2 is really acidic. 7 is neutral. And that's a complicated number. I think explaining this would probably take too long. Aside from the pH, there's just one more thing I need to stress right now. Like, you should know proton, neutron, electron, Bohr model of the atom, the idea that there's a nucleus with electrons around it. But, I mean, you don't need to be a chemist for apes. I've been teaching apes for a long time, and historically, most of my students never took chemistry. So I'm perfectly prepared to help you. If you've had no chemistry, you'll be okay, I swear. I do these things called chemistry band-aids. So when we're getting to a chemistry thing, I'll say, hey, listen, here's what you need to know before we talk about this topic. And I've had a bazillion students take my class without a chemistry background and do fine and pass the AP test and feel successful and go on to college, and many of them become environmental scientists. And I'm not bragging, I just mean to say you don't really need to worry about chemistry too much. I just want to make one point now in this point in our class. You don't really need to understand why chemistry happens. Like, I know this is a big whoop, where for a lot of my students, I'll start babbling about chemistry and they're like, but why does the H become an O? And you don't really need to know that. Like, I can usually explain it. Like, if you want to dork out about chemistry, I'm like moderately good at chemistry. And by the way, we have great chemistry teachers at the high school. Like, I don't know if you like the class. I know that chemistry at the high school level is not really fun for a lot of students, but our chemistry teachers are like really good chemists. Like, I've been around scientists my whole life, and our chemistry staff is like really top notch. So you could always ask them if you want to know why. My point is, think of it like gravity. Like, you can't explain why gravity. Like, go ahead and try, but it's just like, I don't know why, it just does, like, I'm pretty sure if I drop an empty can it's gonna hit, like, I know that. I don't know, gravity. And somebody says why, and you're like, well, it's called gravity. Think of chemistry like that. Like, I don't know why it's an O instead of an H, but it's definitely an O instead of an H. We're going to treat chemistry as something that you just have to know that it happens. And the College Board does have a few reliable chemistry topics. And so I promise I will highlight all of those for you in the course of this class. We're going to talk about a little bit of chemistry here in the ecology unit. We'll talk about a little bit of chemistry in agriculture. We'll talk about a little bit of chemistry in atmosphere a lot, and in water a little bit in mining maybe. Yeah, it shows up throughout the class. You'll be all right. Just look over number 14, check that part of the book. If you have any questions, make sure you ask me. And ditto for number 15. Your study goal lists things I want you to check in the book. And I don't know, maybe you know all of these, right? Like subduction, like when the tectonic plates go under each other, like weathering, the fact that rocks wear out. I kind of assume that like evaporation precipitation was kindergarten and like rock cycle was like junior high. So I don't know. Maybe you already know all these. And if not, please just ask me. I'm using the study guide to point you to the textbook, and the textbook's like, meh, you know all this? So you got to tell me if you know it all. Okay? There were 4 study goals in this assignment in 2.2 that are just setting the stage. We're just trying to get comfortable before we start digging into cycles in ecology. Um, there's going to be a few big cycles. Like from here, we're going to talk about little carbon cycling, like the carbon that cycles through life. Then we'll talk about big carbon cycling, like the global atmosphere, rock, fossil fuels, ocean stuff. On a following day, we're going to talk about nitrogen cycling, which is another really complicated one. There's a lot of specialized vocabulary. Students usually don't like that one, and I just kind of got to grit my teeth and teach you that stuff anyway. We'll talk about a couple of other things like phosphorus or sulfur or something, and that'll be it for chemical cycling. You don't need to know all chemicals, just a few. Okay, I'm gonna stop this video, and I think I'll make one more tonight, so you'll see this t-shirt again.